Okay. So today we'll look at internet, what the internet is and how does it work and so on. Not really how it does it work, that we'll study in the next lecture, but we'll look at the basic concepts of internet, and that's very important, and that's the reason I'm spending a couple of lectures on it, because once you understand this, that will be easy for you to understand a lot of other important concepts based on internet, and you will continue to use internet at least for next few decades. Okay, so this lecture is very important for you to get the top level view of the internet. Okay, all right, just a minute, my okay, all right, you're able to hear me? Yeah, are you able to hear me? Yeah, okay. So please free to ask questions. Of course, go through this cartoon and also go through this news item wherein it says that most of the companies for internet firms are seeing bigger ever denial of service operation. What is denial of service in general? I mean, you deny anybody. So for example, I want to reach to Amazon.com and somebody is not letting me get into Amazon.com. Not specifically, but any user, right? So when website can be made overwhelmed by unnecessary packets from anywhere, there is a denial of service. So another example could be, suppose there is going to be a bid at 10 o'clock and we have to get, me and you, or and I know that you have to get some money out of bank and I want you to deny that service. I will send 10,000 people to the bank who will stand before bank opens up, and their number will come first. They will just do something, nothing, some query or some basic operations, and by the time your time comes up, it will be more than 10 o'clock or 11 o'clock. It's another denial of service operation. So you can think of millions of bots. They are sitting mostly in the devices where you have not set the password, like your Wi-Fi router, etc., etc. These bots will attack a particular website. Okay, that's denial of service. So we'll study that later, and please go through this. Okay, these are the contents I have taken from various sources. These are two beautiful books I find on networking. This is the classical book, Jim Koros and Ross, and this is another good book by Larry Peterson. This is a very old book, but very well written, and they are improving it, and it's available free online. Okay, please, if you're interested in knowing about computer networks, please go through this. Okay, so last class we studied about Moore's law and Nielsen's law and Metcalfe's law, and we'll look at the combined effect of that, and then we look at cyber security of internet, what is the internet, packet switching technology, etc. Largely basics. Okay, please be very attentive because it's going to be a very important lecture for you. So now let's look at why internet is becoming popular is because of the combined effect of Moore's law, Nielsen's law, and Metcalfe's law, right? These are resulting into something that's just wonderful. Okay. Again, to repeat, for those who have been sleeping in the last class, please wake up and please understand these three very important laws. Okay, first law is Moore's law, which says the number of transistors on chip doubles every 18 to 24 months. It means that chips or computers are becoming more and more powerful, and this has been true since 1965. It's true for 50 years. Okay, and you can see in everyday life. For example, last year I bought 128 GB pen drive from SanDisk for about 2,500 rupees. Okay, and yesterday I ordered another one because that's full now. Another 128 GB drive. Okay, and higher version of USB. This is 3.1. This was 3.0. So I bought 3.1, which means that IO speed is higher, for about 750 rupees or something like that, which is 1/3 from what I bought last year. Okay, so we can see every day that more and more chips, more and more transistors are going to chips. It means that now chips are being used to make anything, and then processors are becoming more powerful, memory is becoming cheaper, and so on, right? So we can see that Moore's, note that this is a logarithmic scale. Okay, Moore's law is true. It means that number of transistors per chip is just going exponentially. Okay, all right. Uh, and then we can see is as number of more transistors going into a chip. The simple reason is that transistors are getting smaller in each generation. Size of the transistor is becoming smaller and smaller. It's shrinking almost like 70% in each dimension. It means that in the same area, actually this is a very big size for a chip. Let's say in this chip size, we are able to push almost like 16 billion transistors or even more. Okay, all right. So as a result of that, what's happening? The cost is reducing because you are getting, both things. Chip technology, chips are being used everywhere. The technology is improving. Number of transistors are going more. Okay, and it's becoming popular. It means the cost economics is also playing there, right? Okay, so it means that cost is reducing, and the perform because transistors are growing up, almost like doubling every 18 months. So performance is also increasing. So this is a lovely thing that can happen to anything, any technology, right? Okay. Other thing is that as this is happening, then you are able to use these chips, or processes anywhere. Any application, any device, you will attach it and improve its functions like functionality, control, maintainability. Controls you can do, like from refrigerator, you can sit in Bangalore and control the refrigerator that's there in Mandi. Okay, you can, and refrigerator can itself self-diagnose and tell what's going wrong there, and then possibly repair itself, otherwise help in repairing by somebody else, right? Functionality can go up significantly. All right, for example, remotely you can lock your refrigerator. Okay, you can increase or decrease temperature. A lot of things you can do now once you have control over the functions. All right. Second important law we studied was Nelson's law of internet bandwidth. Now we can see that you yourself would have felt that every year bandwidth cost reduces at your home, right? When you take now, if you take 40 Mbps connection, is available for less than 400 rupees. 100 Mbps connection is available for 700-800 rupees. Kind of very, very cheap. That was unthinkable just 20 years back. Just unthinkable. Okay, so it's almost matching Moore's law. Is around 10% plus minus, I think minus than Moore's law in computer speed. So now computer performance is going up, okay, and cost is reducing for processors. At the same time, bandwidth is also going up, and cost of bandwidth is reducing. Okay, we can see these are playing hand in hand. Reason is that each is helping other technology, right? I mean, for example, why this technology is bandwidth is growing more than 50%? Because of technology in fiber optics or technology in wireless. How does wireless etc. work? I mean, even with fiber, you have to convert, at the end point, optical signal to electrical signal. That requires semiconductor or chips. Okay. Now, if chips are expensive, whole things will be expensive. Now we have fiber to home. From home, the fiber goes from your router, which is electrical signal, you have to convert into electrical signal, optical signal. That is cheaper. At the other end, optical signals are converted back to electrical. That again is cheaper. So both are playing, both are actually supporting each other. Okay. So we can see the bandwidth prices continue to decline despite whatever global pandemic, this, like we have COVID pandemic, etc. Right? All right. Okay. Then we studied about Metcalfe's law. The result of these things is that internet is becoming popular. More and more the people are able to connect the computers, and computers are also becoming cheaper, or even mobile phones are cheaper. Mobile phones are based on what? Mobile phones are based on largely about processor technology. Is a computer actually. Okay. As we have more and more machines connected, okay, and as a result of that, the power that we have overall in the network goes up. This Metcalfe, who was the inventor of Ethernet, says that the power or the value of network increases in proportion to square of the number of nodes or number of end users, for example, or machines. As more machines are connected, more powerful system is. And now imagine how many people are there on the internet. Okay, and each person having multiple of devices. So almost like 43 billion devices are running on internet. So imagine the power of internet. No other technology had this kind of reach or power. None. Okay, and that is making the world flat. Like I'm sitting here able to teach you. All the jobs in IT industry in India has come largely because of combined effect of these three that we have studied, right? I mean, it doesn't matter you are in New York or you are in India. I mean, nobody knows where you are. Okay, and it's helping us tremendously. I mean, the country's number one jobs are coming in IT industry. Biggest service industry is IT industry, right? In terms of revenue, in terms of number of people employed, may not be number of people in terms of revenue, and that has given jobs to all of us, and will give you job to all of us, right? Okay, so it's a very, very powerful technology, internet. We should be grateful to this technology, and we have greatly benefited out of it. I mean, everywhere it helps. For example, when I started my PhD, there was no internet, and I took 2 years to collect references or papers. Just 2 years. You won't imagine. I will write in the postcard and send postcard to somebody in US or Europe, and they will send it by surface mail. And this was the basic idea, that somebody asks for something, please send that. They will send it, right? So after 2 years, now it can be done in just 1 or 2 days. Yeah, 1 day. Your time is actually on searching on internet, but everything is available. Okay, that's the power of the internet. It was impossible to talk to somebody in US just 30 years back without burning your pocket. So largely it's like $1 1 minute kind. It's actually more than that. Okay, so now it's all gone. You can have internet connection, or you can have voice or IP or Skype call or whatever call, WhatsApp call for hours without paying anything. So now we can see the result of this is that advances in networking technology wouldn't have possible without advances in processor technology, and vice versa. Okay, and this has increased capacity of internet, or both, right? Internet and processor exponentially, and as a result of that, popularity of internet became more popular, more connection, more power, more value to end users, right? If my machine is connected only to one website, it has no power. If it's connected to millions of websites or millions of users, I can communicate to millions. Is wonderful, and that's what we have achieved. Any question? All right. So combined effect of all these, we can see now what the world is today. Okay, so now one thing I would like to focus here is that Of course, all these factors are true. It's become popular. It's a de facto communication technology, affordable to everyone. Oh, now almost everyone in the world will have access to internet some way or other. It's touching everyone's heart, right? Everyone's mind, everyone's lives. Okay. Even you go and buy something for 1 rupee. I went few days back to buy dhania, coriander, coriander leaves for just about 1 rupee. And percentage are paid through this thing, right? Google Pay or whatever. Okay, and that's possible today with the UPI and all technologies, all based on internet. Okay, and it supports millions of applications. Okay, now we'll come to this point later. But now, why should we worry about cyber security of internet? Because everyone has access to it. It means that overall attack surface is huge. And we have studied the concept of attack surface. From what points something can be attacked. As internet has grown big, you don't know. Nobody has control over what is there at the end point. Nobody knows what kind of protocol one is running or one has modified the protocols. Okay. I mean, world has defined TCP, UDP, this part of internet, IP, and many other supporting protocols. But one can tweak these protocols and still do some malicious things, right? So it means all I am trying to say is that internet by itself does not provide any security, but it's there everywhere, and you don't have control over who is there, whether Alice is there or Bob or Trudy or Mallory, or it could be anybody, and they can play in different ways. Okay. Now, what can go wrong in internet? Huge lot of things, largely at the endpoints. Okay, so we'll look at some of these little later. But in general, what is the internet? If you visualize internet, what is it? It's nothing but you request to other person, your machine requests to other machine at the end to provide you a pipe, just pipe. And you may want to send whatever you want. Suppose you want to hear a pipe, it's a distal pipe, but you can have analogy with the normal pipe. Okay, I mean, like your physical pipe. What does it carry? I mean, when you buy a pipe, does it say that it can carry only water? It can carry oil, right? It can carry whiskey, or it can carry wine, or it can carry whatever you want. You don't, when you buy a pipe, plastic pipe or whatever pipe or iron pipe, it does not say anything. Similarly, the distal pipe that internet provides does not say anything. Whatever you put at one end in distal pipe will come at other end. And what are you going to put in distal pipe? Nothing but digits, zeros and ones, sequence of zeros. Now these zeros and ones can be anything. I mean, your JPEG picture or video that we are doing right now, all are converted into sequence of zeros and ones. And then how you are going to generate these zeros and ones? This is based on some rules, and if other and follows those rules to interpret the zeros and one can get the picture back. Like my picture that's coming to you is converted to zeros and ones according to some rule. Okay. Okay, well, I don't know whether we are using MPEG or whatever. And that other end is using the same rules to code those zeros and ones back to my picture. Okay. And now these pipes, of course, when we say these pipes, when you buy pipe from home, the shopkeeper will ask, what size of pipe you want. Okay, so these pipes can be of various size depending on how much money you are going to pay. Like on internet, you can take 50 Mbps connection, 25 Mbps, 100 to, or maybe 500 Mbps or 1 gigabit per second. All these pipes are available. Okay, all right. So this is a concept. No, all right. So pipes can carry anything as long as it's a fluid or zeros and ones, and at any speed. Now here the speed we consider is the size of the pipe or bandwidth. 50 Mbps or 100 Mbps or whatever. Speed, of course, speed at which it travels, signal travels, is of course speed of light. Okay, let's not get into it. We'll look at propagation a little later. Okay, now what is really needed? Each machine must have IP address. Otherwise, you don't know from where to where you are sending. Now, note that this is not the actual pipe, but you get illusion of the pipe, distal pipe. Illusion. Actually, you send a packet. Okay, and these packets follow some path and come to other end. When we say more bigger pipe, it means that more number of packets you are able to send. Okay, but once packet travels from one end to another, it has to know where to go. It's like your postal. See, it's just analogous to your postal system. Like you drop a letter, you write from whom to whom and all that, and then it contains some text or whatever, and then postman will look at the address, give it to one office, postal office. From there it goes to another post office, goes to third postal office, and so on. It finally reaches your hostel. Okay, so now on internet, when internet was created, the designer wanted to make it as simple as possible, and that gives a flexibility. Okay, they say that we are just going to provide this kind of digital thing, pipe thing, and now intelligence, how you are going to create these bits and how you are going to interpret it, how do you are going to secure it, all is at the end devices. Pipe has nothing. So internet, from your machine, when it leaves your machine, your router, it goes to ISP, to second ISP, and so on. Now all these things in between only look at the destination IP address and few other things and send the packet. It does nothing more than that. It does not look at whether it's coming from Mallory or from Alice or from you. So internet does not provide any security of its own. So it means that who has to provide security in internet? It is you, the end user or end devices, and the protocols. That when we say protocol, Alice and Bob will have exactly same protocol for communication and receiving and sending and receiving. The same protocol. Okay, protocol is nothing but set of rules. For example, say Alice will say, hello, can you send your public IP, can you send me your, public key? Okay, Bob will send public key and then Alice will do something. All this is set of rules. Okay, all right. Now the question that we need to ask is that we know all this. Now, what is the internet? And why it has become so popular? One reason for popularity we have seen because of 3 laws. And so there must be some other architectural beauty, right? What is that beauty? Okay, it says so the world existed before internet with lot of networks, right? Like PSTN, cable operator, like still you will find cable TVs, right? I mean, there will be cable overall antenna somewhere in the building, and they will distribute TV signals, right? Or channels, right? Like So cables will come to almost to TV. There must be a box, and then from that you get that whatever channel. It means that that cable may contain 80 to 100 channels, and you tune what you want. Okay, so now some of these, so this cable network existed all over the world. Okay, and there were other technologies which we are not discussing it here, like Ethernet, local area networks, and so on and so forth. And then we had technologies like Sonnet and so on and so forth. Okay, now the question is that these technologies existed for very long, and they are also, like in cable, you can use few channels for digital communication, apart from TV channels, right? So all these things existed. Now, how do you want to use this infrastructure to support internet? That was the beauty, right? Now internet says that whatever technologies you have, okay, you should be able to transport my IP packet. Okay, so the higher layer or IP layer will give to lower layers, whether it's running based on circuit technology like PSTN or cable or whatever. It will say, I will give you IP packet, you should be able to send it to some other point on the way. That's it. It's like this, that your mother is sending you packet of laddu, she put it in the box and writes your address, say for example Alok at IIT whatever. Okay, she will not say that it has to go over a truck of certain size, or it should not go over cycle, or it should not go over flight or aeroplane. She will say that she will be asked by courier company that you create a box of this particular size, and that's the format. Okay, your name and your address and your mother's name and address and all that, and just give it to me. Now this packet can go over what? Anything, you don't know. It can go over cycle, for example. Courier guy will come cycle. Plus from that courier office, it will go over truck to some other place where they are collecting. Then it will go over some, say maybe scooter. Who knows? Maybe it will go over maybe flight, and so on. So now this base, and at each point in time is going to next point, based on what is your address. From Bangalore it's going to Mandi, then the first courier guy will send it to maybe Delhi. From there guy will look at that is for Mandi, then will send it to Shimla or maybe Chandigarh, from there to Mandi, from there to command, from there to your hostel. At any point in time, for routing of your laddu packet, they will look at where the person is and node is, or what is the destination address. Same thing, they say that internet is not bothered about whether packet is going over PSTN or cable or a satellite or Sonnet, as long as you can send the packet to another point in the route. Okay, it is all fine. So that's the reason it becomes now a connecting technology for, or it's interconnecting technology or inter network for various type of, or connecting various types of networks. Okay, so internet now connects various types of networks, like we have seen Ethernet. It has also core network. It is mobile backhaul, which can be 3G, 4G, 5G, whatever. Data centers and enterprise networks, which are within company network, and so on and so forth, right? And technologies could be any. Underneath technology, IP runs at layer 3. Underneath technology could be anything. It could be DSL, it could be ATM, it could be Wi-Fi, it could be Sonnet, or whatever. The hundreds of technologies are there. So IP doesn't bother. IP simply says that I'm giving you packet, put this inside your bigger packet and send it to other node. Okay, so we'll come to these points later. So what is the structure of internet? You have a machine. How do you connect this machine? What is the way to connect the machine to internet? You ask service provider, right? Say for example, I have Geo. Right now I'm using Geo connection. I've asked Geo guy, company paid them money, they came and installed Wi-Fi router, or from there the cable runs to their access network. Somewhere or other they are collecting all these signals in a router and then sending it to the other links. So first thing that you do is that you connect your machine through access ISP. Okay, for example, Indian access ISPs are Airtel, Jio, Act, BSNL, whatever. Okay, VI, Tata, etc. Now you have connected them to access ISPs. Like I've connected my machine to Jio. But what does it has to, and my signals right now are going to you, and you may be some other ISP. Okay, so there must be some way from my ISP signal should go to your ISP. Okay, so it means that these ISPs must be interconnected, and there must be some hierarchy of these ISPs, so some structure in which these ISPs are connected, or internet service providers are connected, right? And who is going to define this hierarchy? There must be some body that will define this, how this can be connected. Okay, all right. So now look at millions of such access ISPs. Note that I am using access ISPs, like local Airtel here. Okay, this is where I am in Bangalore, Airtel or Jio or whatever. And there are millions in the world. How we are going to connect them? One way is that just fully connected network, right? You would have studied fully, if you have studied graph theory, you would have done fully connected graph. Is it a good solution? No. Why? In order to connect n nodes, fully connect n nodes, you need order n square connections, right? Okay, as n grows big, this n square goes very, very big. It's impossible. So now better solution is that you have global ISPs, second level of ISPs. Okay. Now the question is that can we have just single global level ISP, which internet have various routers on? This symbol shows router. Okay. So is this a good design? Yeah, I'm asking you guys. Yeah, please answer. Yes or no? Nitya, are you there? NB, Nitya, B22180. Sanchit Munjal, are you there? Can you, both of you, call me later after the class? Okay, anyone?
So no, it is not a good design.
Yeah, why? Very good.
There is a very slow. If we connect every ISP to every other transit ISP, then there will be a
Yeah.
delay.
Yeah, very good point. See, this may be point of congestion, right? Or efficiency can be low, right? And let's assume even then they are able to design very powerful one, but there is single point of failure. Okay, if this goes bad, then nothing can work. Okay, and bigger point is that whom you will allow this to? I mean, would you allow AT&T or Verizon or whoever? So it means that now you cannot just monopolize it to one company, and everything is commercial in the world, right? So now you will say that yes, there can be many such ISPs, global ISPs. These are global ISPs, right? ABC and many more. Just three have been shown here. It can now, of course, then you need to interconnect them too, right? Okay. So you need to interconnect, and these are called IXP, Internet Exchange Points. Okay. All right. So there are second level of ISPs or global ISPs. Now there are some giants in the world like Google or Amazon or Microsoft and so on. They all these companies may want that something I should create for my user which is content oriented, right? Okay. Okay, all right. Which will come little later. Then of course there can be some kind of peering link up. So this is the next level of structure one can define. And then there can be, instead of each unit of access ISPs directly connected to global ISPs, there's another hierarchy called regional ISP, like like Airtel, for example, or Geo, on which internal will connect to various access ISPs, right? All right. And there can be some content service provider like Google, Microsoft, Alchemy, and so on, so forth. Okay, they will say that we'll cut across all these and create our own stuff. Okay, and some own network where I can send data very effectively or contents very effectively, right? So now the structure is something like this. We have one level of tier 1 level ISPs or global ISPs, then their content service provider like Google, and then regional ISPs, and these are all connected through internet exchange points. Okay, and then there are access ISPs and so on. And these access ISPs are connected to regional ISPs or to IXP or tier 1 ISP or global ISP. Okay, all right. So this kind of structure exists. All right. Okay, this is about internet structure. All right. So next thing is that what does internet provide? It provides connectivity to various types of networks. What are those networks? We have looked at all these networks, like we have seen layer 2, layer 1 networks like Wi-Fi, for example, Ethernet, Sonet, cable network, and so on and so forth, which can carry or which has a channel to carry digital signals. And then we'll say that you just, if the the path of packet is like this, let's assume this is the structure and this source and this is the destination, then we'll say that your packet comes here into this router. It will say now in between there can be Wi-Fi, here there can be cable. Now IP packet will travel over Wi-Fi to this point on the path, and then it will gets converted into again IP packet, and then again destination looked at, and then this node decides to send it over cable, then it goes over cable. Now this IP packet may sit over any kind of bigger packet or container. We don't care, how your laddu packet from your mother comes through, as long as at the end you should get the actual laddu packet. Okay, so now what is really important is that there has to be unique address for each communicating station. If your address is not unique, the laddu packet will never reach you. So similarly, each machine should have unique address, and that we call is IP address. Okay, and then what can be there in the packet? Now courier guy tells your mother this is a packet format. On the top you write the name, address, etc., like a box here or certain dimension. Okay, and write here on top name, address. So he will not say that they'll, what you can put it, as long as it's legal, right? You cannot put it, of course, something which is banned, but whether your mother puts laddu or barfi or gulab jamun or whatever, or cake, it doesn't matter to courier guy. Similarly, these packets can contain zeros and ones, and that zeros and ones can contain anything. You can code data, voice, video, etc. in terms of the zeros and ones. This is the beauty of internet, right? So now all it carries is zeros and ones, reliably or unreliably to other end. We cannot say even reliably. It just transfers sequence of zeros and ones to other end. That's it. Okay, now these zeros and ones can carry anything. This is unlike now you compare this with PSTN phone, or PSTN phone in your home, fixed line phone that can carry only voice. It has only voice, is designed for only voice. Can it carry video communication like we are doing? No. Can it carry large file? No. Right? So in the past, these networks have been designed only around one application. And now we are coming to the technology which says that I don't care. Whatever zeros and ones you give me at other end, I will try to send it to other end. That's it. That's all it says. I will try to send. It does not say I will send. If there is a congestion in between, it will drop. Okay? Or if the router fails, then packet will drop, and so on and so forth, right? And that's the beauty of the network. So anything that can be converted into zeros and ones can be transported over internet. Wow. Now you can say that I can convert my book into zeros and ones, I can convert newspaper into zeros and ones using some format, right? Like even the files have some format, some metadata, and then metadata tells how to interpret this, what this zeros and ones contains, like pic or movie or whatever. It can be anything now. It can be phone call, video call, transaction data, and so on forth, right? So now its characteristic is that since it sends only packets, okay, it's extremely flexible. When we say extremely flexible means what? If some places in the world, the courier guy will deliver it just by walking. For example, from my gate, community gate to my flat, if they don't allow their vehicles like motorcycle or whatever, they come home, they will just walk. Okay, yet deliver me. So last leg of delivery can be very slow. Maybe they will cover, say, 200 meters in 5 minutes. Okay, very, very slow. And this minutes is very slow, right? Okay, similarly, internet speed could be anything, or pipe of the band, or bandwidth could be from kbps to gigabit per second. But internet should work. It's like your packet, laddu packet can come over cycle, first by walking, first by cycle, then by truck, then by flight, then reaches at your end by courier guy walking to your hostel. But that packet reaches, right? Similarly, IP packet reaches from one end to other end, whatever be in between. Layer 2 technologies, what speed it can travel over. Okay. Second is fault tolerant. If part of the network is faulty, yet IP packet should reach to other end. For example, your mother's packet of laddu reaches Delhi and there is a congestion into Chandigarh route, then they route it through Shimla. There can be a flight to Shimla. They will dynamically take decision to route it to Shimla, and from there it will come to Mandi, and from there to command. Okay, similarly on internet, your packet passes through large number of routers. Okay, and is this source and this is the destination, and if packet goes this way and this router is knows that next link is highly congested, there's an accident or something, this road has a lot of congestion, they will, if there is a link exists, it will send the packet to some other path. So when your application sends millions of packets, assume, Not all packets follow the same path. Depending on, sometimes they may follow, but very likely that they may not follow also, right? Okay, depending on congestion in the network, depending on some routers may be faulty and so on and so forth. So internet provides similar kind of flexibility, right, or fault tolerance. Okay, now it is end-to-end principle. That's very, very powerful, because internet just provides a pipe. It says just give me IP packet, I will try to deliver it to end. That's it. And in that packet could be anything that we have discussed, right? Okay, and then it is left to me at the end whether it is a laddu or barfi or whatever. Okay, so content could be anything, and I have to make sure that laddu reaches safely to other end. It does not get stale in 2 days, right? I mean, instead of maybe bundi laddu, your mother will make atta laddu, and then that survives for 15 days. Is now it's left to end, and when it reaches you, you will check whether quality is okay or not. Okay, so it's end-to-end principle that works. So now, as a result of, there's no restriction of application type. So now millions of applications at that points. Okay. Now, because of that, it can carry data for any application. It means that internet or IP packet can carry anything, and any application can be coded now in terms of zeros and ones, and these zeros and ones filled into this packet. It means that now we can have, as long as two applications at the end are same and can interpret data accordingly, according to the rules of that application, or semantics, syntax and semantics that's well defined, then you can design any number of applications. Like we have voice over IP application where voice goes over packet, like what we are doing is voice over IP or video over IP. Okay, using protocols like SIP, MAGACO, and all this. A large number of protocols. I don't know what the current one is using. Or video conferencing over IP, which was unthinkable many years back, and millions of applications. Okay, and all that is based on packet switching technology. Okay, how does it work? Internet is exactly like your PSTN network, sorry, your courier service, or sorry, yeah, courier service, postal system. I'm sorry, not PSTN but postal system. You go to post office, drop a letter or box, and write receiver's name, okay, your name, and put a stamp and give it to post guy. Similarly here, each node creates IP packet, sends it, and there is a router. Like in case of postal office, there is a postal system, there is a postal office, or GPO sometimes we call, or whatever, post office. Okay, so packet goes here, this guy will look at a destination IP address and send it to one of the outgoing links. If there are multiple outgoing links, it will just send it to one of them towards the destination. And who decides what link it will send? There is a protocol for that. It is called routing protocol. Like there are ISIS, there is MGCP, etc., etc. Not MGCP. I'm just forgetting. Anyway, all right. So this is the technology, which is, this technology is based on packet transfer. Like here, there is a packet, your application will create, then it will go to your, give it to your machine, because application is running on a machine, then IP packet is created, it will be sent to this switch, which will decide where to send, will send here, and finally it will go to destination. Okay, that's it. All your application has to do, convert this into stream of zeros and ones, which is loaded into IP packet and finally goes to other end. Okay, so now assume that this is the PIC that is to be sent, and this is a link. This PIC has to be converted into zeros and ones. Okay, there's a possibility only part of this will be come in one packet, so part will send into one packet, second part will go to second packet, and so on and so forth. and you put a header here, which is nothing but a metadata. This is the actual content, zeros and ones. This will say destination IP address, source IP address, etc. etc. This part we call as payload, and the other part here is the header. Header tells where to go, like on your box or sweet box, your mother will write your name, say Alok, at whatever hostel, say hostel Parashar, for example, room number whatever 101 at IIT Mandi command and all that. Okay, so this is what, this is not the actual laddus, these are help courier guys to transport your laddus. So this is metadata or header. Okay, so the packet may go. So now take the analogy. If your mother is sending packet to you, or Alice is sending it to Bob, what does it require? It requires destination address, like your address, hostel address, packet size, content weight, method of transporting packet, whether courier or simple post or whatever. And then there must be some network for actually transporting it. Okay, and then there must be some protocol or some routing method how your packet will go in postal world, right? Whether it will, you'll say very fast, you want to pay more and it should go fastest way, then it could be different, and so on so forth. The path, so path is also decided, and of course you need sender's address and other information. Okay, similarly, from this analogy, it's the box analogy, we take your postal system analogy. If we have IP or internet, then unique destination address, which is your hostel address, room address, etc., now is IP address. Packet size, content, and weight defines IP packet format. So for example, this header, what this header contains, there must be some number of fields here. Okay, and then what is the size of this payload such that you can recover it. All these things are there in header, right? And then zeros and ones, methods of transporting packet. Now your packet is going over Ethernet or or other technologies, or using IP, UDP, TCP protocols. Network for transporting protocols is layer 2 and layer 3. Routing protocols BGP, OSPF, ISIS. Okay, this decides what route it goes to. From Bangalore, for example, it can go to Bombay, or Bombay to Delhi, Delhi to Chandigarh, and so on and so forth. Or it could be any other thing. So this route is decided by routing protocols like this. Sender's address and other info, right? So that's it. To summarize, Internet is a de facto networking technologies. It provides global connectivity. It is extremely flexible. It's extremely flexible. From small bandwidth to large bandwidth can work. It's extremely fault tolerant. Okay, and it's because of all this combined effect of Nielsen's law, Moore's law, and Metcalfe's law. Internet has no intelligence of its own. It's like flat pipe. It's only at the end node intelligence lies. So security is the responsibility of end nodes only. If you are not securing your network, if you are using HTTP instead of HTTPS, you are not encrypting your data. So now it's your problem. Internet does not give any security guarantee. All right, that's all. Any question? Okay, can we have just a minute?